Hello everyone and welcome to my last instructional video. Today we're going to be working on the assignment for Wednesday, July 22nd. Today we're doing two-step inequalities. So we've done one-step equations, we've done two-step equations, one-step inequalities, and now we're just going to do two-step inequalities, okay? It's not going to be too difficult. We've got our notes right here. We've got two options. We can do our Wizard assignment or we can do our Google Slides. Down here we have a video from Khan Academy. It's not super engaging, but it's got good information, okay? It's good stuff. If we take a look at our notes right here, I'll bring up this PowerPoint. It starts by telling you what an inequality is again, okay? So if you forgot what went on last video, we've got all these different symbols other than our equal sign, okay? This right here is our greater than sign. Example, 7 is greater than 3. This symbol right here is less than. So this one is less than. 3 is less than 7. If you haven't noticed by now, we're reading it from left to right. So if the left side is smaller, that means it's going to be a less than sign. Let's take a look at this one. This one has a bigger side on the left. So this is going to be a greater than, but it's also got this line underneath it. So it's a greater than or equal to, okay? Just like that one, this one also has that line, but it's got a small side on the left. So it's a less than or equal to, okay? If you need more of a refresher, go ahead and watch my last video. Solving inequalities. Just like solving one-step inequalities, we do the inverse operations to undo what's being done to the variable. Remember, our variable wants to be alone. We've got to get rid of everything else, make the variable alone, okay? We're kicking everything else to the other side. For two-step inequalities, we will undo by working through PEMDAS in reverse. PEMDAS is just your order of operations, okay? It also says down here, note, just like when solving one-step inequalities, you will multiply, if you multiply or divide by a negative, the inequality symbol will need to be reversed. Okay, we'll review that in a minute. This right here is a good example. Let's go ahead and do one of our own. So let's say we have 5y minus 3 equals 12. Okay, some notes. Off to the side, I wrote box variable, inverse operations to both sides, and if we multiply or divide by negative, we flip the sign, okay? First things first, box our variable. What is our variable? Well, in this case, it's our y. Remember that your variable is just a letter in your equation or inequality. So we've got our box variable. What does this box mean to us, okay? This box to us means leave it alone for now, okay? We're gonna worry about other things. So what do we need to move? Probably this minus 3, right? Because remember, this y needs to be alone, and we can't move the stuff in the box yet, so it's gotta be this 3. This 3's gotta go. What is the inverse operation of minus 3? It's gonna be plus 3. Remember that inverse operation just means the opposite. And what we do to one side, we do to both sides. So we added 3 to this side of the equation, so we also need to add 3 to this side of the equation. Let's make this an inequality so we can do this. So cross out your 3's. 12 plus 3 is 15. We drop down our sign. Okay, pretend this was always this right here. I was doing an equation, but we're working on inequalities. We drop down everything in our box, our 5y. So we have 5y is less than or equal to 15. Is our variable alone? Nope. We've got to get rid of this 5 now. And what this means is 5 times y. If you see a number right next to your variable, this is multiplication. What is the inverse operation of multiplication? Division. It's opposite of multiplying by 5? Well, dividing by 5. So we divide by 5 on both sides. our 5's cross out. We have y is less than or equal to 15 divided by 5 is 3. Well, did we multiply or divide by a negative number? No. So this would be our answer. If we wanted to graph this, we'd have our number line. We'd have our 0. Let's go ahead and count out to 3. And remember, if it's a less than and equal to, or greater than or equal to, then it's got to be a solid dot. So there's going to be a solid dot on this 3, and this arrow is pointing to the left. We know that y is less than, so it should be going towards a less than 3, towards 0. Okay, let's go ahead and do another one. Let's not erase our notes. I guess I got to go. All right, let's go ahead and take a look. What else they got? All right, let's do one with a negative. Okay, just keep that in mind. There's gonna be a trick to it. So we have, let's do negative 3. It looks awful. Negative 3x plus 1 is greater than equal to 10. Okay. We don't have our notes off to the side, but we do need to remember those things. The first one was to box our variable. Our variable in this case is going to be the x here. So we have negative 3x in our box. Box means to leave it alone. Don't touch it. We've got to get rid of this 1. The inverse operation of plus 1 would be to subtract 1. Subtract 1 from both sides. The 1's cancel out. 10 minus 1 is going to be 9. We drop down our box. Negative 3x. We drop down our sign. So we have negative 3x is greater than or equal to 9. Is our variable alone? No, so we're not done yet. We got to keep going. It's negative 3 times x. What's the opposite of multiplying negative 3? Dividing negative 3. So you divide both sides by negative 3. Negative 3 divided by negative 3 is just going to be 1. So we're going to be crossing those out, dropping down our x. Now we're going to drop down, no, we're not going to drop down our sign yet. 9 divided by negative 3 is going to be negative 3. We could drop down our sign, but is this sign right? No, remember that there was a trick to it, okay? So we did multiply or divide by a negative number. We divided by negative 3. So we divided by a negative number. So this sign right here needs to flip. And what it means by flip is that it needs to face the other direction. So right now, the big side is facing towards the x. So we know the big side now needs to face the negative 3. So it was like this, and then it became this. Okay, went from greater than or equal to less than or equal to. Let's see if they have anything else super spectacular here in the notes. Doesn't really look like it. Let's take a look at our wizard assignment. I think there could have been some stuff in there that was slightly confusing. Let's just take a quick look. We've got a video reminding you about inequalities. Translate this into an algebraic expression. All this right here means is write it like, for example, like x is less than 5. Okay. So this one says one more than 5 times a number is less than 18. One more, so that'd be plus 1. 5 times a number. 5 times a number. In this case, we don't know what a number is, so it's x is less than 18. Okay. That's how you do that one. You can go ahead and have that as as a freebie, okay? There's no other ones like that. That one was kind of hard. I don't know if y'all have done that yet, so there you go. Select a possible solution that would satisfy each inequality. Remember that we can have multiple right answers. Let's go take a look. Not that. Let's take a look. Okay, so we had -3. We have x is less than or equal to -3. So if you take a look on the number line, we have 1, 2, 3, -3 right here, and x is less than, so it's this way. So anything -3 and less than, those are all answers. So our answer could be -3, it could be -4, it could be -5, it could be -6, it could be -6.6. Who knows? Okay, there's a lot of different answers. There's a lot of different things that it could be. So when it's asking you which possible solution would this satisfy, keep that in mind, okay? It might not be the answer that's obvious. You should know that graphing, remember if there's a line underneath, it's a solid dot. If there's no line, then it's going to be an open dot. Big hints right there, big hints. And the rest you should be all right with, okay? I hope y'all have enjoyed. Enjoy the rest of your summer. You've got like another week off, and then I guess it's back to some e-learning. But it's been real, guys. Thank you.